So we'll be using the Anaconda, which is a Python toolkit for data analysis. So we will be heading over to anaconda.com, and here we'll be on the product choosing the open source distribution, the individual edition. And here we'll simply click download, and then based on your operation system, you're going to choose either one of these, Windows, Mac, or OS. I'm on Windows, so I have chosen the Windows distribution. So you simply just click here and get the installer. Once you have downloaded the installation file, simply just open it up and let it install on your computer. It might take some time because there are a lot of dependencies and stuff that needs to be set up, and you can also see it is quite a large installer. So just let it take its time, and once that is installed, you should be able to find an application called the Anaconda Navigator, which looks similar to this, where you will be able to access different applications. For example, we are going to use the Jupyter Notebook, which was also the one we saw at the beginning of the video, where I have the table with the two company stocks. But before we can open that up and start fetching our finance data, we need to install a package from Yahoo Finance, which is the one that we're going to use to fetch the data. So we'll be going here on the start, simply just type Anaconda prompt, and in here you need to execute this. So pip install Yahoo Finance and upgrade. So basically just copy this, put it into your Anaconda prompt. I have already done this, so I will not do it again. But once you have executed this command, you can check that it is installed correctly by typing pip show and then the packet name, like so. And as you see here, you have the location and you see the version that you have installed, and then there is a short summary. So basically, finance market data downloader, which is all we need. So now that we have this installed, we are ready to move on. So we're going to launch this Jupyter here. And basically this is a web-based notebook. I will just zoom out a bit, where we can execute Python code from within our notebooks, which is quite nice. So what we can do here is to make a new notebook, and as you see here, it is displaying all the folders that I have available from not only from within Jupyter, but generally in my folder structure. So as you see here, I have, for example, the standard music folder on Windows. I have a Postman folder as well, and I have the Anaconda. But what we need to be concerned about is that we need to create a new notebook. So we'll be choosing Python 3 as our notebook, because we want to be able to execute Python code from within. And in here, you can see that we are able to actually execute code. For example, you can test it by typing 1 + 1 and execute this, and then you see 2. So there is some execution going on behind the scene. So that is fine, and we will just run this again. Okay, so now we are ready to move on. So the first thing that we're going to do is to import the necessary libraries. So we'll be importing Pandas, which is a data analysis library, very popular. So we'll be importing Pandas as PD. Then we'll be importing the Yahoo Finance that we just downloaded. And then we'll be using Matplotlib, because later on we're going to, in the next video, after we have imported our financial data, we are also going to show it in a graph. So we are going to do a bit of manipulation with the data just to graphically illustrate it. But that is for the upcoming videos. So we are going to import matplotlib.pplot as PLT, like so. And then we're going to define what stocks we're interested in. So for now, we'll just be wanting to import Apple and Xiaopeng. But you can define any public available stocks that is listed if you want to fetch some other companies, for example. But for this, we'll just stick with Apple and Xiaopeng. So here we'll define their stock code. You can find this by just searching on a company and then Yahoo Finance, and you can find their stock code right here. So and then we'll be using Xiaoping, and that is the two stocks that we're interested in. Then we can say Yahoo Finance, the package that we defined right here, dot download. Then we input this stock list here, so stock, and then we need to define the start of the data that we want to look at, so the period. So we'll say from, for example, 2010, and just at the start of the year, and then the period should end at, let's just say 2010, and then just the 1st of November, so like so. And then we just execute this. Oh, let's just see, UF stock download. Oh, I need to execute this first, and then this. And after a while, the download is complete. It took just a few seconds to download the data, but as we see now, we have a nice table where we see the data from the two companies. And as you see here, the Xiaoping is basically null in the start of this table because the company was not created in 2010. So there is no data to fetch. This is why we see the null value right here. But here you can see what their close value, what the highest value was on that particular day, the lowest value, what they opened at, and the volume of stocks from the start period that we defined until the end period right here.
Everyone should have the opportunity of influencing the world of tomorrow by learning high-impact tech skills. Take back control of your time and stay efficient by planning your daily tasks and learning activities using the Academy Planner. Browse through your favorite personal resources and keep track of your learning progress. Our belief is that people learn differently, and we do therefore support resources from around the web to ensure the best possible experience. The Social Hub enables you to connect with like-minded users. You can either dive into already established topics or be a first mover and create new topics that can inspire other learners.
Hello and welcome to Winslope Academy. This is part 2 in our Python financial stock analysis tutorial here on YouTube. So in the last lecture we saw how we could fetch stock data into our Jupyter Notepad using Python. And in this lecture we are going to learn how to take that stock data that we displayed in a table and make a graph out of it in order for us to compare different stocks based on their closing price. So in the end of this video we will end up with a graph like this, where we can, in this case I have just selected Tesla, Xiaoping and Apple, but you can basically select any stock that you want to compare and illustrate this in a graph. So we're picking up where we left last in the last part. So we now have this graph of the two stocks, Apple and Xiaoping, and we now want to extend upon this. So first of all, we're going to make a variable that will store our stocks that we are fetching. So we'll put them in here in this variable called stocks. Next off, we want to define the data that we're going to put into our plot graph. So we will define a variable called data, and we will assign the stocks that we are fetching here. So basically this table, but we need to define what data from here we are looking for. And in this case, we want our graph to show the closing price of the stocks. So we need to define that we should take the close column, so the actual closing price of the stocks on a given day, and then we will simply just make a copy of that into our data variable right here. So if we execute this, we see here that, let's see, stocks here. So as we see, we got an error because stocks, which is this one, were not defined as the right object. So by adding this S here to differentiate them, we see that we have now downloaded the data, and we are having two because we have the Apple stock and we have the Xiaoping stock. Now we just need to make the plot. So we will say data dot plot, and here we will define just some of the layout parameters. So we will say the figure size should just be 17.8 pixels, and then we will say that the font size should just equal 18. And you can change these if you want either a smaller or larger font size, or a bigger or smaller graph. And then we simply just say that the PLT, which we imported in the first part, remember the Matplotlib right here, so that is what we're going to use now because we assigned it at this PLT. So we'll say PLT.style, and I have chosen to use the Seaborn graph. If you are interested in other graph types, you can always look them up by searching Matplotlib and then just see the plot styles that are available. But we will stick with the Seaborn for this video. And then we basically just need to say plt.show. And let's try to run this. Let's see. Oh, we need to do like this. And let's see. We have the my mistake. It's here, of course. And here we have the graph. So here we have the blue line that we see here. That is the Apple stock, which is indicated right here. And as we see, the Apple stock had data from 2010, whereas Xiaoping were not founded at that time. So we only have data from this small area right here. And as you see, it is not very easy to see the exact values of this because the Apple stock have such a high range. It ranges from around 8, I think it was at the beginning, and now we are at around 135 or something at the highest point. And that is why we are not seeing the Xiaoping stock that much. But we can of course try to just remove Apple just to see here. And let's see. And then we run this. And here we have the Xiaoping stock from the 1st of September until November, where we see the stock is really bouncing back and forth. So as we saw in the beginning of the video, we also could compare, for example, Tesla to Apple just to see another stock that is also very valuable right now. So we could say BL and Xiaoping and TLSA. And we have fetched now 3 downloads completed. And let's see, wasn't that the code for Tesla? I'll just see. Tesla. Oh, let's see, stuck. TSLA. Okay. So TSLA like this. And let's download this now. And here we have the right Tesla stock. So as we see here, they're following each other nicely, but then in 2020, the Tesla stock really kicks off, which you might also have heard about in the news, or if you are really into finance, you have probably seen this on finance news sites, because Tesla has really been a crazy stock this year. So this was how you could take your fetched stock data and make a graph out of them. So you can basically pick any stock that you want to compare and put them into this graph. So in this lecture, we'll be making a normalized graph like this one, where we can get a better understanding of how well a stock performed based on the price. So as you see here, this chart is a lot different from the one above, where we see that both Apple and Microsoft are much closer to the performance of Amazon, because we have normalized the values and taken apart that Amazon started off in a total different price tag. So let's get into it. So the data that we have right here, which this graph is based on, is just taken right out of the Yahoo Finance library. But if we dig into the data, we can do this by clicking data.head. And again, if you haven't watched the two first parts of this tutorial, I recommend you to do so, where we'll be building this stuff right here. So if you have already seen this, you will know that we are having a variable data which contain the stock data that we are using here. So now we are taking a look at the head of this data. And if we execute this data.head, we'll get this output. So here we have the Apples, Amazon and Microsoft. And this is the start period, which we are defining here when we are fetching the data. So as we see here, Apple is starting at 7 and Amazon is way over 100, whereas Microsoft is kind of in the middle, closer to Apple, of course, than Amazon. And this is what gives this huge difference when we look at this graph, because they are starting off in total different price tags. So we want to normalize this data to even out the price difference and just look at the performance of the stocks instead. So the next step that we're going to do is to use this ilog right here, where we are choosing 0 for the first row. So we are basically taking the row here, which we see Apple 7.6 and Amazon and Microsoft. So by using the ilog and defining 0 here, we are taking the first row, where if we took 1, we are of course in the next row and so on. And if you want to, for example, look at just the first row and the first value of Apple, you can do like this, and if you run this, you will see right here, then we are only getting returned the output from the first row of the first element in this array list, which is Apple. So we'll just remove this because we are interested in the entire group of data. The next thing that we're going to do is to divide these. So we are going to divide the first row with its own value. This will give us a normalized value of 1. So this list right here is actually displaying these values that we have right here in a normalized version. So here every company is starting off at 0, and then we will get a normalized value in the upcoming rows based on their performance. So here we'll see that Apple goes under the start value, so the normalized value of 1, and the two other companies do this as well. So this gives a lot better indication of when these start to take off, and we can really get into the performance of the stock based on the price, of course, by normalizing the value. But we don't want just to have a normalized value of 1, because normally when you normalize, it's a good practice just to normalize down to 100. So the way that we can do this is by, of course, taking the data variable which contains the data, and we are going to divide this, but we are going to add on the multiplier of 100. So by adding this line right here, you will get this list normalized and multiplied by 100, meaning that we will start off by 100, like we see right here. So now when we have this data where every company is starting at the same point, we can start to understand how well they performed. So now we are simply just taking this data and performing the same actions that we did in part 2 of this series, where we're making the plot. So we are basically copying this code right here, but we want to do it on our new data, the normalized data. So we create a new variable called norm data, and then we say equals the normalized value where we multiply by 100. Then again we define the plot parameters, the size of the chart figure and the font size, and we again use the Seaborn style and basically just show this off. And this gives us this value right, or this chart right here, where we see that at one point here, we're actually seeing that Apple, or 2 points here, is performing better than the Amazon stock, whereas of course in the end the Amazon stock really kicks off, but Apple is following a close pattern right here and is not that far actually from the Amazon. In numbers it is of course a bit off, but this graph gives us a much better understanding of how well the stock performed, whereas if we are only looking at the raw data of the price tags right here, it looks like Amazon not Amazon, but Apple and Microsoft, the blue and red line, is performing terrible because they are just in the bottom right here, and it looks like they are really worth nothing. But that is not the case. It is just because Amazon is having such a high price tag that it makes these look like real underdogs. But by normalizing the value and looking at the performance of this normalized value, we will get a much better understanding of how well each stock performed. So we could, for example, here try to add some other stocks. So I will be adding Google and Intel just to see how this performs. So we'll go up here and we will take the list we have here and we will be adding Google. So let me just check the code for this. This is like this, and then we have Intel like this. So we'll be executing this first. This will download the data. Then we'll just try to rebuild this graph just to see where we see this is based on entirely on the price tag without normalizing, where Google started off higher this time than or not this time, but Google displays the point that when you are having a higher price tag, you really make these bottom stocks, Microsoft and Intel, and also Apple, look like they are worth nothing. But again, this is not the case. So if we just try to follow the approach here again, we see that Google is starting off by 300, which makes Apple starting price of 7 look like, yeah, again, it's worth nothing. But when we are looking at the performance and follow this down, I will not be executing this because this will just add Google and Intel here, and again, this will just normalize. But if we then use this one just to illustrate it, we now see that when normalized, we see that Google and Microsoft is actually close to each other. And let's try to see how this looks in a graph. So this was the graph before. And if we execute this again, let's see. So Apple and Amazon is again following nicely. Then we have Microsoft, which is performing in the end better than Google, whereas Google have in the years 2014 or 13 here up until 2019 more or less performed better price-wise than the Google stock. So Microsoft performed. Oh yeah, the Google stock performed better than the Microsoft. And then again, not again, but we see that Intel is, well, it's not performing that great compared to these other 4 stocks. So this is a way that you can take your fetch data and the knowledge you have about creating a stock chart and do some analysis by normalizing the values to get a better understanding of how each stock is performing based on their price over a period of time. But for this tutorial, we're going to learn how we can make a plot like this, where we can, based on the standard deviation and the mean values of a given company's stock history, determine whether there is whether there is a high return value, meaning the higher chance of profit, compared to how risky the stock is. So the standard deviation will display how big of a deviation there is between the numbers in the history of a given stock. So for example, we see here that Tesla is having a very high standard deviation compared to Amazon and Google, meaning that the Tesla stock is in the top risk boundary here, whereas it also gives a chance of very high profit. So it is very risky, but also gives quite a good profit, whereas a stock, for example, like Amazon, is not that risky compared to Tesla, but it gives quite a good return value, whereas if it should be equal to Tesla, where Tesla is more or less topping both parameters, the Amazon stock should be, for example, here if it were in the same area as the Tesla stock. But Amazon is actually having a quite good mean value compared to the standard deviation, so the risk value. And then we have Google, which have more or less an equal mean and standard deviation value, meaning that it is giving a low chance of return, whereas it is not very risky to be in. So the way that we're going to get here is to do the following. So in the previous parts we have already seen what libraries to import, and we have seen how we can fetch data. And for this example, as you saw, we are using the Google, the Amazon, and the Tesla stock. For this example, I have chosen the period that we are fetching from 2015 to 2020. And then we are basically just fetching this. Again, if you haven't watched the previous parts, I encourage you to do so if you want to fully understand what is going on. So we'll just jump more quickly over the parts that we have already covered. And here we see the plot that we learned to make in part 2 of this lecture. And as we see, we have the Amazon stock, the Google stock, and the Tesla stock. So we will return back to this in just a few seconds. The next thing that we're going to do, if you want to look at the beginning of the table just to get a quick look at what you have fetched, you can use the data head. And here we see that in the period where we are starting from, the prices of the stocks were for Amazon 380, 529 for Google, and 34 for Tesla. So this is the beginning of the period that we have selected. Then we can take a look at the percentage change for each day. So this is what we are seeing here by taking data percentage change, and then we have the percentage change for a given stock trading day, and we also have some null values because the stock market is not open at all days, but we're going to fetch these out by simply doing this percentage change drop in a. So this will remove all null values from our data set. And then we can just use the describe measure. And when we're using describe on our stock data, it will return to us the total count of rows for each stock. So we have 1,439 stocks for all of them because they are all fetched from the same period. Then we see the mean value, which is the one that we are building on here in our plot, and we have the standard deviation, which is the mean and the standard deviation is the two parameters that we're going to use. But you can also see the min value and the max value, but we are only interested in the standard deviation and the mean value. So what we're going to do is to take these two values from the describe parameter and simply just isolate them so that we only have the mean and the standard deviation in our sum variable right here. So we are just excluding these two and these 5 values here. So when we are printing out this sum, like we have here, we see that we are only now having the mean and the standard deviation. So what we want to do is to take into account that we want the mean value and the standard deviation for a whole trading year, and not just the mean value and standard deviation given each single day, because that is what this is showing. So if you're just taking the mean, as we see by isolating this here, we are getting a mean value and a standard deviation, but these values are based on the mean value giving all days, whereas we want in this example to take the mean and standard deviation for a whole year. So this will give us the mean and standard deviation for 5 years, given that we have just chosen this period right here. The way that we're going to do this is to take and define the sum mean, which is the data that we have in this mean column here. Then we are going to add into our variable mean the same value, but we're going to multiply it by 252 because that is the total amount of trading days for an average year. And we're going to do the same with the standard deviation, whereas we're going to multiply by the square root of 252. So by doing this little calculation, when we print this out, we now have the mean and the standard deviation for a whole trading year compared to the mean and standard deviation based on each trading day. But that is up to you whether you want to see the whole year or you just want to display for a given trading day. So with this sum variable here containing the values for a year, we are basically just going to make our plot. So the way that we are going to do this is to say the sum, which is the variable which now contains this mean and standard deviation. Then we are using the plot scatter. We are defining what the x value is, what the y value is. Then we are going to define some cosmetics, meaning the figure size and the font size. You can change these if you want. So you can just make a bigger, smaller graph or change the font size, that's up to you. And then we are going to add this annotation right here. So if we don't do this, let's just try to remove this and run this. You will see that we just get some dots. So we have no way of knowing which stock we are actually looking at. So by adding this line here, where we are taking a for loop over each index in our sum, we are going to annotate each dot with their I value, meaning the names right here. And then we are simply justifying here the place on the graph that these are going to be based on the dot. So this is again cosmetics based on the x and the y values, whereas we then define here how far away they should be and then the font size. So you can also change these number values here if you want some either smaller text, or you want it displayed further away or closer to their dot point. So this is basically how you do a nice risk and performance graph of stocks based on the mean and standard deviation. And if we go back here to the top graph, let's try to see if we can get an understanding of how these two are working together. So remember that Tesla is now represented as a stock, being high performance and very risky, whereas Google is not giving that much, having a quite low performance, but is also not that risky. With that knowledge, let's go back here and just see how the stocks have evolved. So the reason why we see that Tesla is having the best performance and is also very risky is because that we need to take a step back from this graph, where we quite clear see that Amazon is a very good stock. It is have evolved very much. But if we again look at the price of these stocks, we should remember that each stock started at a different starting point. So Tesla started at a very low starting point, where it suddenly takes off and jump very high. So this is giving that we now see that it has a very high performance, but it also have a very high standard deviation, meaning that it's risky. Giving that the values are jumping very much in this stock, whereas Google is having a low performance but is not that risky, and that is giving that the stock has even evolved quite pretty over this period of time, but giving that it started at a little over 500 and now we are just closing in on the 2000 price tag, it is not that quite of a jump that it has done, because as we see, it has its ups and its down period, but over time, of course, it has given quite a good profit if you bought it here. So that is also why we don't see it in a minus, because you have still earned profit on the Google stock, but the profit is nothing compared to if you had the Tesla stock in this period that we are comparing. So this is another way of looking into stocks and analyze how they are performing with this mean and standard deviation, so the performance and the risk of the stock jumping back and forth, which could give you a better understanding than just looking at a graph like this, where most people will take, for example, the Amazon stock as the best performance stock, but it is actually not when you look at the values and their starting points.
Everyone should have the opportunity of influencing the world of tomorrow by learning high-impact tech skills. Take back control of your time and stay efficient by planning your daily tasks and learning activities using the Academy Planner. Browse through your favorite personal resources and keep track of your learning progress. Our belief is that people learn differently, and we do therefore support resources from around the web to ensure the best possible experience. The Social Hub enables you to connect with like-minded users. You can either dive into already established topics or be a first mover and create new topics that can inspire other learners.